Okay, the recording started, and I hope I'll be able to record this session and upload this onto the every classroom. So what we normally do is offer webcasts similar to what I'm doing, and based upon the needs of the class, there will be 3 or 4 offered during the length of the program. We also have 2 teaching assistants from 3 different classes attending as well. They'll be doing some things of similar nature as and when it is needed. So the first and the foremost, what I was trying to explain and illustrate in this webcast is more geared towards SQL, because SQL forms a major chunk. With text. Please mute all your phones, please. Okay. So the major chunk of the syllabus or major chunk of the program until week 6 focuses mainly on SQL. Then we move on to Tableau. Then we move on to Python. So week 2 onwards, the pace picks up, and lot of work is needed and lot of effort is needed from your side. The TAs are assigned to each of the course. Please reach out to the TAs. I have provided the formats. And the TAs also conduct meetings on a weekly basis. And for my class, Isaac manages the TA, and he has posted his availability. Please take his assistance. The TAs are only to guide you, not provide you solutions. Meaning, if there is an error, they will point you where the error is. They will not be fixing the error. So you need to practice how to do, what to do, and those kinds. So for instance, there is an SQL error. They'll point to the manual where it is, how it is, what to do. If at all, if you are not able to follow, they'll give an example, but not fix your code. So that is what has been clearly outlined to the TAs. They'll be doing the same thing, and you will be, but with their assistance, if at all, if you need anything, they should be able to resolve. And finally, you always copy the instructors when you're communicating. In case if there's a delay on the part of the TAs, we will pick it up and we will respond to you and able to assist you in the way it is possible. This is an online program, and we will try to provide as much assistance as needed not to be successful. So, having said this, let's start the SQL. Please mute your phone, please. Okay, the first one, what we are going to cover in this WebEx is SQL. Here, what we are trying to do, because some of you are new to the programming, new to the course of data, I thought let's give you an example, because when I graded, I would say almost 50 to 60% are having difficulty in understanding SQL. So let's look into what is SQL. SQL is nothing but structured query language. When you say structured query language, it is a way how you execute commands and how you get information from the database. That is called a structured query language. Now, let's start with the basic fundamentals. So what is the basic fundamentals? When you take a table, the database consists of tables which do have rows and columns. For instance, there's a table called employee, and employee table has employee ID, and name. So the headers are called the columns. So for an example, if let's take this. Okay. So
Prasan, excuse me, your voice is coming in and out between loud and muffled. It is extremely difficult to hear you.
1 second.
Thank you.
Can you see if this is better?
Yes, that appears to be better. Thank you.
Okay. So please let me know if it is not clear or audible. I'll go slow. Also, since we are late starting, if I rush too fast, please let me know to slow down. I'm here to help, here to assist, but I just want to cover within an hour a huge chunk. So please bear with me. I will pause at various sections. You can ask me questions. So and also, if at all, if you're not audible, please you need to, because I cannot see any of your chat messages. Somebody has to come on the phone, hey, and let me know this is what is happening, okay? So now when you look at an employee table, let us say an illustration here. Employee ID is 1 and the name is John. So next row will be 002 and it will be like this. So these two are called rows and the one which is the header is called columns. So a database, let's take what is only required for this course for you to understand the basics so that you will be able to do your assignments. What I'm teaching, we cover this in one semester, which is DBST 651 program. We are not going to that depth, but what is required, what is need to be understood for this course, and what will be helpful for you to complete your assignments. That's what I'm focusing. Okay, so now I showed an illustration of a table. I explained to you what is column and what is rows. So these two are rows, and the top row, the top one is called the column or the header row. So database consists of tables which have columns and headers, and tables are interrelated by relationships. Then each table or tables do maintain something called as entity integrity, okay, and referential integrity. These are two important concepts you need to understand. So for instance, if I showed you the illustration 001 John, and I can also say 001 is Mary. If I have data like this in a table, it loses the integrity of the data that is available in the database. So the tables are also called as entity in some form. So it lost its integrity. That means the data got corrupted. So there is no way you can prevent from users from entering 001 for John and also 001 for Mary. In this example, it lost its integrity. In order to protect the integrity of the data and the entity or the table, there is a concept, something called as entity integrity. That is what we enforce. So entity integrity is enforced by something called as primary keys. Okay, primary key is required. When there are primary keys to a table, it enforces the integrity of the key values. So in this example, what I have shown, employee ID is a primary key. So that is, when you enforce that as a primary key, you will not be able to enter a duplicate value. It will give you primary key violation has happened. It's a SQL error you will get. So that is what is enforced by primary key. Now let's take a second table called course. In the course table, we have something called as course ID, course name. 00 is called data analytics. Let's take data 620 is called data analytics, and DBST 651. Okay, this is called as Relational Database Management System. Okay, so there are two courses, and there is a, let's take this as, instead of calling this as employee ID, let's take student table. Okay, student ID. Okay, so it simplifies for this illustration of this thing. Now, there is a need in your organization or in your university to create a database for storing student information and enrollment information. So that is the requirement given to you. When the requirement comes in, there will be rules stated. So in order to enforce the rules, we create primary keys, we create foreign keys, and we create relationships. So what is that? So I explained you what is entity integrity. Now, let's say the university tells you create a database to store student information. Okay, a student can okay, I just typed something out of the blue. Okay, now your technical people and or your technical managers and requirements is given to you so that you give it to your staff to create. So they're asking to create a database to store student information, and a student can be enrolled into one or more courses, and enrollment into a course is optional. So just take only this kind of information. Now, you have created a student table, you have created a course table. Now, you also want to know who is enrolled into which course. So we create another column called student ID. Now, we say John has enrolled into data analytics while Mary has enrolled into DBST 651. So if you want to store information like this, these two tables become a relationship. They are related to each other. Now, why we have the student ID here? So it will have a foreign key validation or foreign key relationship. So when you store a foreign key in a related table, it goes and validates that key variable is a valid variable in the prime table. So in here, if you enter 005, it will say foreign key relationship violated because 005 is not available in the student table. That is how you have foreign key relationship or referential integrity is maintained between the primary and the secondary table. Normally, when you have primary keys, those tables are called as parent tables. The tables which have foreign keys, they are called as child tables. Just keep this concept in mind. I'll help you understand why I'm talking about this. Okay, now, so we have student and we have course and we have referential. We understood what is entity integrity, and now we're talking about referential integrity. So referential integrity is enforced by creation of a foreign key between these two tables. So why I'm telling as a parent and a child table, because when you drop tables, you have to always drop the child table first, then drop the parent, because the relationship exists and it will not allow you to drop. And when you are creating, you have to create the parent first, then you have to create the child table. That is the rule in the database concepts. Or else it will not allow you to create because you are having a relationship. So this is how you create entity integrity and referential integrity. For the sake of this course, just understand primary keys and foreign keys. So primary keys enforce uniqueness in the table, and they maintain entity integrity. That means integrity of the data is maintained by primary keys. Then for foreign keys, they are useful for managing referential integrity. That means when you connect two tables, you need a relationship, and relationships are established by foreign keys. And the primary key of the parent table becomes a foreign key in the foreign key or the child table. That is how you establish. Now, as I finish explaining, I will ask Deepa, who is the teaching assistant, to show you the tools, show you the virtual desktop. Then we will also show you what are all the software and how you do simple commands, creating tables, selecting tables, and then she will show you an ER assistant also creating tables. So look into it, and we'll also tell you some of the mistakes students have done during the process so that you will not do the same mistakes for your week 2 assignments. So we have covered primary keys, we have covered foreign keys. I have explained you entity and referential integrity. Now, there are relationships. You have 2 tables, now student and course. Now, if you look into this example, what I have typed, a student can be enrolled into 1 or more courses. So it is a simple English. There are 3 types of relationships: one-to-one, one-to-many, and many-to-many. So there are 3 types of relationships you should always remember. Now, a student can be enrolled in 1 course. That becomes one-to-one relationship. A student can enroll into 1 or more courses. It is one-to-many. Many students can be enrolled in many courses. That is a many-to-many relationship. So please keep this in mind. You should never have a many-to-many relationship in an ER diagram. When you have many-to-many type of relationships, it will not enforce the cardinality of functions between 2 entities clearly. So when you have many-to-many relationships, you have to break that relationship into 2 one-to-many types of relationships. That is the rule when you are converting. You are ER diagram and you are rationalizing or normalizing the diagram. So remember this, don't make this mistake. If you have many-to-many, it becomes 2 one-to-many relationships in the ER diagram. So these are the 3 types of relationships. Now, there is a cardinality function on the relationship, which we will illustrate while we are showing ER assistant. When you do one-to-one relationship, then if you have, in my example or in my requirements, I said a student can exist in that student table without enrolling into a course. That means a student can enroll into 0 or 1 course or 0 or many courses. This 0 becomes optional, and optional is a cardinality on the relationships. That is what is the meaning. So you have required and you have optional as the cardinality on the relationship between the 2 tables, which is student and course. So this is what you need to understand. So let me recap so far. So I gave an example and illustration what is in a database, which are tables. The tables contains columns and rows. The column is the header row, and rows are the data where is stored in the table. Then each table or the tables are enforcing entity integrity and referential integrity. Entity integrity is normally enforced with primary keys. Referential integrity is enforced via creation of foreign keys. For this course, just remember primary keys and foreign keys. So primary key maintains the uniqueness of the data in the table. So when you are making uniqueness, you need to understand which column you have to create as unique. Some people have, or some students have created name as the unique column. If you create name as a unique column, it's very difficult. For instance, there could be another John. It's possible. So when you say name as the primary key, you cannot insert another John because it will say primary key violated. So you have to be careful which column you can create. Normally, a numeric column becomes the primary key. Now coming back, what is a foreign key? I said, in order to enforce referential integrity between 2 tables which have a relationship, we create foreign keys by taking the primary key of a related table as a foreign key column into the child table. And these 2 tables are connected, and when the connection, the referential integrity is enforced, meaning it will go validate if the course is valid or is the student valid? I can go vice versa also. For instance, in the student table can become the child table by creating a course ID as the foreign key. Now, when I do the course ID here, when I enter, instead of data 620, if I enter data, it will say foreign key column violated. So that is how you do it. Then you also need to understand which becomes the primary or the parent table, which one becomes child tables. That's all by looking at the table, looking at the rules, looking at the data, you can understand which tables becomes parent and which becomes child tables. Okay, so that's what we have covered so far. Now, there is something called as normalization. I will give a very, very simple illustration. Let's not go deeper into normalization. It is a 3-hour lecture we cover in the DBST 651 program. Let's pause here. I'll take some questions before I go to normalization. Do you have any questions? Is it clear so far? Yes or no?
Yes.
I just have a quick question. When you said that you were going to make the student the child table, wouldn't that get like recursive? Like if you added the foreign key to the student for the course number and then you had student under the course, wouldn't that be recursive and they both are parents and they both are children?
No, I did not take this column out. I was trying to tell you, you could convert the student table as a child table. So I take the course ID there. You are correct.
Okay.
I have to remove this column there, else it will be recursive. You're correct.
Oh, okay, I got it now. Thank you.
So now I just corrected it.
But I have one thing to add on that. Like if you do put the course ID up to the course number, a student could be enrolled in one or more courses. So the course ID will repeat and the student ID will repeat. So it would be better to put the student ID in the other course number. So you need to understand that situation.
That is what I was trying to tell. When you need to understand the data, what you are storing, and your ER diagram, so that you can create which one becomes a parent table, which one creates a child table, and how you have to pencil out in a sheet of paper. So as you rightly pointed out, that will become an issue here, the way I have illustrated. So the previous one is the best option for us in the example. Right now, you are perfect because the way I showed you, you can have only one student taking only one course. So that's where we will go into normalization. I'll explain that in a simple terms. Any other good questions?
It's me, Isaac, the FA. I was just pointing out something.
So please think about all these scenarios. It's not that simply creating an ER diagram, then we grade it and then we mark down your grade. But you need to think, because this is the course you're learning. And when you can make mistakes here, we will be able to guide you. In the industry, you cannot, because this guy doesn't know anything, Okay, now let's move forward with normalization, because I don't want to waste a lot of time. So normalization, normally in the industry, we go to 3 normal forms, okay? The higher the normal, it's costly and expensive to maintain. So we go to 3 normal forms. Okay, well, the first, let me give simple illustrations, then I will tell you a simple way to say if your table is normalized or not. We can easily tell. Okay, what is the first normal form? First normal form, see, if you have redundant data in a table, that becomes violation of the first normal form. So you need to make sure the redundant data is not there. For instance, 001, okay, this is just an example, okay. So if you have data, how I have shown, then it is violating the first normal form. So in order to make this meet the first normal form, you have to remove the redundant columns. So this becomes a table which meets the first normal form. Just understand that. Don't worry about normalization. There won't be any questions on normalization, but you need to create an ER diagram, normalize. I'll explain in a very simple way. So, but I'm giving you the technical way how you go through it. Now, this table is clear on the first normal form. Now, there is something called the data flow diagrams are there, and also there are diagrams to understand from which column is identifying another columns. So you create diagrams. Then from the diagrams, you dissect that table and then say these two tables are related. Then the third step is you have to see if a non-key column identifies another non-key column, it's a violation of the third normal form. Then again you have to dissect the table. That is how you take a big table, you keep simplifying it until you go to the third normal form. So the first normal form, your redundant rows, you make sure the columns are not there. The second normal form, you make sure the identifying columns are correctly identified in a way and you group them together to form separate tables. The third normal form, a non-key column identifies another non-key column, that becomes a violation. Say for example, for instance, let's take this illustration, just the first row. Okay, now student ID is the primary key here. Okay, other columns are non-key columns. Now data identifies data analytics because the course is data 620 and it identifies data analytics. If you are having such scenario in your table, it is not normalized. So a non-key column cannot identify another non-key column. So what we have to do, we have to break this table. So we have to remove these two columns and create another table, course description. Then connect these two tables by foreign keys. So that is the third normal form. So what is the simple and easy way to identify if the tables are normalized or not? Okay, first you have to delete. So you have, these are called as litmus test. So if you have a table, if you can insert a row into the table with the required information without impacting other rows in the table, that means there is no insertion anomaly in your table. The same way, if you want to update a row or a column in the row, if you are able to update that column or row without impacting other columns, other rows in the table, then there is no update anomaly. The same way, delete anomaly. So if you test your table, if there are no anomalies of this format, that means your table is most probably normalized. Okay, so that is 99%. If you test this, you should be in a good shape with a normalized table. So that is what we do. But there are technical steps. We go one step to the other step to the other. There are 4 steps in order to create a normalized entity relationship diagram. We teach this normalization chapter in 3 hours in DBST 651, and we give them a huge table and we ask them to normalize, and there are steps to go through the process, and then you arrive at a normalize. It is not that course here. Here you need to understand there should not be an insert anomaly, delete anomaly, update anomaly in the tables what you are creating for your entity relationship diagram. And when you enforce your ER diagram, your relationship should be meaningful, your cardinality should be meaningful. Then keep in mind one strong point. When you create your ER diagram, never have many-to-many relationships. If you have many-to-many relationships, you are violating the entire ER concepts. You should convert many-to-many into 2 one-to-many type relationships. That concludes your ER diagrams. It will most probably 95% you are meeting the needs of your ER assistant. Is it clear? Questions? Deepa, are you there?
Yes, sir.
Deepa? Deepa? I don't know.
I do have one last thing, Isaac.
Sure.
Try also when you do ERD it's not 100% unneeded, but is redundant, and redundancy is something at least database people like me don't like. Try not to loop your ERD, meaning that you will see all these lines between relationships between all your tables. If you loop it around to another table, that means you are pretty much doing another redundancy of getting 2 relationships again. So it just loops around. There's no need. So that's all I'm saying. Hello.
Yes. Hey, Deepa? I don't know. She's not there. Oh, she's having an audio issue. Okay. Isaac, do you want to show the ER assistant VDA? She's having some issues with her audio. Hello? Hello? Can you hear me?
I can hear you. I can hear you.
Okay, I don't know what Isaac is not able. Okay, let's. It looks like Deepa is not able. Okay, I can show. Okay, so this is the virtual desktop. I would always suggest to use the HTML access, which is easy rather than going and installing the client.
Okay, sir, I'm not seeing anything on the screen.
Oh, you're not? Okay, 1 second.
I don't know if it's just me.
No, I did not.
Oh, it's coming up now. I see it now.
Okay. So what I was trying to tell is, please, when you go into, use the HTML client, which is easy and no installation is needed. Once you select the HTML client, click on our data. So this is our ER assistant, which is already there. Make use of this ER assistant. This is, if you want to install, the executable is there in the class. You could install it. So this is called as entity. So this is a new one. Then this is entity. So let's create a new entity called student. Then we want something called course. Okay, when you close, two tables are created for you. It's very simple, very easy, right? We need columns for this table. Double click this. Columns are called as attributes. We create a new attribute called student ID, and we are making that as a primary key. It's a numeric length of 10. Then we are creating a new column called name, character, length of 30. So it's done. That's all. Go to course, create columns, course ID, and we are making its primary key. We want it to be a numeric 10. Then course description, we want it to be a character with column length of 30. Okay? Close. See? You're done. Now, these are the two tables. Now, we have enforced primary key and entity integrity. Now, we want to say a student can take one or more courses. That is relationship. So what is the relationship? We are creating between student and course. Okay? It's a regular relationship. It is between a student table, course table. One student can take many courses. I think somebody has to mute their phones. So one student can take many courses. Okay, let's keep optional for the time being. Okay, I'll show you what it is. That's all. Now, this is called as Crowfoot notation. Okay, there are multiple notations are used in the database industry, and the ER assistant uses Crowfoot notation. Now, how you have to read a student, this way we are reading, can be enrolled into 0 or more courses. When you're reading from the course, a course will have 0 or 1 student enrolled. That's all. That is the meaning of this relationship and the illustration of the tables. So you have a student table, you have a course table, you have a relationship. If a check diagram is that, okay? There are no errors in the diagram. You're fine. Now, so in this table, I can insert however rows I want. Then you say select count star, you have 10 rows. If you have inserted 10 rows, then you try to insert one more row. What is the required? Student ID is required. Name is optional. So, but we will insert student ID and name. So you can insert without any issue. That means insert anomaly is not there. You can delete a specific row. You can update a specific row. That means there are no anomalies. This table is normalized. Now, with the relationship, can you also do that? Yes, no problem. Then, in the ER diagram, when you create, there are tools which allow you to show foreign keys. When you create a foreign key in this ER assistant, you will get an error. That is understood. So for instance, so you can create one more attribute. See? You will get this, but don't worry about this, okay? If you want to show foreign keys in the ER diagram, it is not a preferred method. Normally, they don't show foreign keys. Some diagram tools do show them. But in this ER assistant, when you show foreign keys, it will say it is all sorts of errors are there. So try to not show foreign keys in this ER assistant. Okay. But when you put this relationship, it's understood that the course has a student ID as a foreign key column. So it is very meaningful, well understood. Now, this is how you change this. Now, one to many, right? You can say many to many. See, the notation changes. Okay? Now, one course can have one student. See, the notation changes. So the relationships are the business rules. That's how you enforce the rules in the database, by enforcing the relationships on the tables. Okay. Any questions on the ER assistance, ER diagram?
So, question, so you're saying you don't put the SID in the course because you don't need to list the foreign key?
No, if you want to list the foreign key in the course, don't use the check diagram feature.
Oh,
okay?
Oh, I got it. Thank you.
But if you want to follow ER assistant tool, how it is used, don't show foreign keys. I'm okay with that. If you are a traditional technical person, they always show foreign keys in the diagram. If you show foreign keys, I'm not going to penalize. But don't get panic when you use the check diagram feature.
Thank you. That was very helpful.
Sure.
Hi, Professor Prasanna. This is Deepa. I'm sorry, I had a little audio issue. I'm calling via the phone.
No problem. Yeah.
I just want to clarify for the last question. Some students have, if you do include SID in the course table, some students have done this in the past. They've included the words, the letters FK inside brackets, indicating that this is a foreign key to this table, if it makes sense. Because this tool doesn't support foreign key representations, one way to get around that is you can still enter an attribute called SID, but inside brackets enter FK, like what Professor Prasanna just did. What this will it will quickly show you that this is a foreign key to this table, and you may get past the consistency errors.
Thank you, Deepa.
Yeah, and I'm sorry for the audio issues.
No worries. I don't know. At the same time, Isaac was not able to hear as well. I was calling him.
Yeah.
We had backup.
Can you hear me?
Both backup speed. Yeah, I can hear it.
Oh yeah. Well, I'm just wondering real quick because I never liked ER Assistant. I always used Data Modeler, and that's free as well. So I'm just wondering why ER Assistant. That's my only question.
So for the purpose of the assignments we have, I think ER Assistant serves the purpose pretty good. I don't know that we should be going to a different tool. Yeah.
Okay, that's fine. Data Modeler does resolve all that, not all foreign key, primary key. It actually shows everything, and then data types as well. So that's what we always use for ERDs. But that's it.
Deepa, you want to take over to show SQL Workbench?
Sure I can.
Okay.
Hey guys, sorry for the mix-up. I think I may be ready to finally show you some things. All right, let me start sharing my screen.
Any other questions with ER diagram? Before you can share your screen, Deepa, as we speak. You go ahead.
Okay.
So you are clear for the assignment, right? I passed your presenter role to you.
Okay, sure. All right, let me know if you guys can see my screen.
Yes.
Okay, so I'm in the virtual desktop environment, and I use the web-based environment because there is nothing to install and it's always available for me to use. So let me backtrack a little bit and show you what I do. So this would be your desktop environment when you first log in. And I hope all of you have your passwords, your root passwords by now. So when you first log in, I hope all of you have enjoyed doing your first assignment. So this is, and you've already used this instance. So this is how the application looks, or MySQL Workbench looks when you first log in, and there's a secondary sidebar that I've already hidden. So let me, are we creating a new database and inserting rows? Is that the objective?
Yeah, show them the create command, insert, then a couple of joins.
Okay, sure. So let me first create a test database. So right now, when I run this command, it's going to create a test database for me. So right now, it looks like there's nothing, but if you refresh, it would have created the database for you. And then you always want to use my demo so it knows that it has to go to this database to run your commands. And then you can create a table. In this table,
Hello?
Hello? Yeah.
Yes, this is Isaac. I'm just trying to tell you, because Oracle did take MySQL, you can use the Oracle way of select the schema name dot, and it will use database, but either or. That's it.
Okay.
Isaac, can you say that one more time?
Oh, yes. You could do, instead of saying use database my demo, you could actually, once you create the table, of course, you could do, just like Oracle, you could do whatever the schema name is or the database name dot, and then the table name. So you do select star from my demo dot student, and we'll still load the data. They added that feature, and that's why everything is not called database anymore, but schemas. Oracle changed a couple things. But that's it. Anyway, go ahead.
Thank you.
All right. Okay, so I have created a sample create table statement, but something is not looking right. It's not happy about something. Can somebody help me out? Can you figure out what I'm doing wrong? So if you look at the first.
You don't have the data type.
Yeah. So what is it I'm missing?
The data type.
Data type. Okay. All right.
You're also missing the semicolon behind use my demo.
Okay. Okay. So I guess it's all happy, and we ran our commands, and that created our student table. But you'll see that right now it's empty. So if you want to select, you could do a select statement. But because there's nothing in the table, it comes back with a bunch of nulls.
Deepa, question, why make the primary key a varchar, not like an integer?
I guess I just picked the wrong data type. I did not focus that I had another, but you could make it you have to make it an integer, sorry. It has to be an integer. It can be a varchar, but for the purposes of this demo, I'll just go by what I've written so far. So now I can insert into.
Also, remember, sometimes it's necessary. Like zip code, for example, it's popular to be used as a primary key, even though it shouldn't have a dash, so it has to be a varchar. Other aspects of mixing letters and numbers, again, that has to be a varchar. So it depends on how you want to set up your primary key.
So that will be our first insert statement, and it's still not happy. Okay, so now that's our insert statement. Now if I run this, it's going to insert the first row. So now I can run there. So you could do a few more, and this is a tip I learned. So you can create the first one, copy. This is a quick way to create inserts. Okay, since I've already run my first insert, I'm going to run this, and we can run another select statement. And so that's our student table. Next, we can create a table called course. Okay. All right. Okay. I'm sorry, the virtual environment is kind of slow to react today. Okay. So I have another mistake here. Could somebody spot it? Okay. So I'm just gonna go. I fixed it, and I'm gonna try to create this table. Let's see. So that's my course table. Run another select. Okay, it's all empty. So now I'm gonna insert some rows into the course table. So had I defined my student ID to be an integer, I would have done what I'm just doing. Instead of enclosing that the first value in single quote, I could have just directly defined an integer. So I had already run that. All right. So now I can select from my course table again. And if you look at the section here, you'll pretty much you will be able to tell what problems you have in your script right away. So like here, you see how it says duplicate entry 1 for primary key. It's because I had already run the insert statement, and when I was trying to run it the second time, it gives me that duplicate entry message. So just by looking at this output section, you can kind of pretty much quickly figure out what the problem is with your script. And sometimes if I cannot figure out, I just Google the error code and find my way out. So that's about it to create and insert rows into a table. What else did we want to show the person?
Can you show some select statements and joins between two tables?
Okay, so for that, I guess I have to update the table here. So this is, if I have to show just a quick select statement, where so that would be a select statement, a quick select statement from this table. And so I'm not able to do a join statement, a demo for join right away, because there is no relationship that exists between student and course table as of now. I haven't defined a primary key, and that's the reason I won't be able to do a join right away. So in order to do that, I have to add a foreign key into course table, and I have to link up the student and the course table, which is what I'll try to do right now. Am I doing this right? No, all right. Let's just drop the table and recreate it. It'll be easier. What am I doing?
If it's okay, I already did a join on the two existing tables. If you want to.
Sorry, say that again.
I did a join already on the two existing tables on the silk schema. if you want to be a little bit easier on you. There, two tables exist that has a ID between both. The actor table and the film actor table. And actor ID, the commonality between both. So, so you can do a join between those two tables.
Sure.
If right now, if you like Scala, start with that.
Oh, okay. All right.
Yeah, the tables underneath there, there's actors table with actor ID as a column. And then there's a film something on there as well. You can make it more complicated, but I have to go through all the tables.
Okay, thanks.
But there's a common ID between film actor _ actor and actor. So that you can do is simply join between those two tables. And it works fine. So,
okay.
But I didn't need to actually do a star because it did it twice. But
yeah.
You get it.
Okay. But, so I'll just move over to this schema then first.
And you actually can show the difference between inner join, full out join, and left and right join. I'm just
gonna do inner join for the sake of this demo. I think we're going over already. Okay. So to do a join, the typical need for a join is because you will need to show some columns from the first table and some columns from the second table, and you'll have to join them based on some common field. So like we were just talking about, the common field between actor and film table is, at this point, is actor ID. So there's actor ID in this actor table, and then there's where is it? Okay, sorry, that example didn't work out.
The two tables are actor and film _ actor.
Oh, okay. I'm sorry.
Yeah, it's fine.
Okay, so there's film _ actor and there's actor table. So you'll see that there's a common column called actor ID, which you can join. So if there was a requirement for me to show a film ID for a certain actor, how would I do that? Because the film ID is not here in the actor table. So to do that, you will have to select a couple of columns from actor table and a couple of columns from film actor table. So let's say I wanted name, last name. So those are columns I need from the first table, and then I need film ID from the second table. From join film. So that would be this is the simplest form of join. So it says demo.actor does not exist. Okay, so this shows me, this is a simple inner join that shows me all the first name and the last name and the film ID. So this is for each film actor, and this is the number of films they have acted. So you'll see that this person has more than one movie that they acted in, and similarly, and so on and so forth. So for every film ID, the reason you're seeing duplication is because this person has acted in more than one movie, and because this movie, the film ID is distinct, you're getting one row for each film ID, if that makes sense. So in order to join three tables, you would do 2 joins. In order to join 2 tables, you would do 1 join. Does anybody have a question?
So whatever Deepa showed you will be useful in the upcoming assignments. The concept is when you have 2 tables, you should definitely have 1 join. If you do not have join, it creates a cross-product relationship or cross-product, meaning if one table has 5 rows, second table has 10 rows, if you don't join, you will get 50 rows instead of 5 rows, because 5 rows will be the minimum common between both the tables. So you should get a maximum of 5 rows depending on the data. So that is what the relationship and the join. If you have 3 tables, minimum 2 joins are required. So likewise, you have to make sure how you do the join. If you don't do the join, it will do a cross product and you will be panic. I think it is week 4 or week 5, you will be getting select statements and things like that. So that is why I asked her to illustrate the creation, insert, and a select. Okay? Anything else you want to understand?
The only thing I want to add to is the alias names. So if you look at the script here, I'm calling actor by a short name called A, and film actor by a short name called B, and then I'm using that alias names everywhere in the script, so I don't need to type out the whole the table name one more time. So if I had not used these alien names, I would have said actor.first name, actor.last name, and then film_actor.film ID. So in order to avoid that, I'm trying to use short names or alias names in the script, and this will be a good practice if you're joining more than 2 tables. It's always good to use alias names so you can debug your script easily.
Yeah, and I like using bigger than just one letter because it gets a little confusing for scripting and other people looking at your scripts, but that's just me. For the alias. So.
Are there any other questions, guys? I know we're kind of rushing through this, but was there anything that you want me to go over a little slower?
See, all this illustration is mainly to help you with your assignments. The common mistakes have been done, which is basic, fundamental, and we are trying to show you what are the things you need to watch out, how you need to execute, and how you need to make sure you don't get into those errors. Okay? So if there are no other questions, we'll call it a day. I truly appreciate taking time to join this. We will have one more SQL session. I will ask either Deepa or Isaac to show you examples of joins, insert a lot of data so that you could understand the complexities of joins. Then after the week 6, we'll have a session for Tableau. Around week, if time permits, on the same day, we will show you Python illustration too. If not, we'll have a separate session for Python as well. So that to show you how to write simple code and then how to execute the code. We'll have those sessions as well. So any other questions or thing? Okay. Okay, Deepa, thank you, and thanks everyone for taking time. I am going to stop the recording. Okay, so
Yeah,
we'll
thank
post
you.
the recording also. Anything you need, please reach out to the TAs. Also copy the instructors. We'll be there to help you. If they are occupied and sometimes there could be a potential delay, TAs might. See, today I had 2 TAs. Both had audio issues. So please understand, and we are here to help you. Thank you.
Thank you. Have
Thank
a good
you.
evening.
And by the way, I am going to be available for the next hour. So if anybody actually needs any help after this word, you can just contact me via email. Okay? Hello? Oh, these people still going on. Ah, that's what I needed to do.